Hello everyone, in this video we are going to talk about a very simple problem but involving complex numbers. Well, the problem is given to be this identity square root of I plus square root of minus I is equal to square root of 2. This is a very beautiful looking identity and we need to prove this. Well, here by square root of I we mean the principal square root of I, and so is for square root of minus I. But what is principal square root? Before we go into that, we must understand what is the general situation, and then in a moment we'll see what is the meaning of principal square root of I. Well, this is very clear to see that square root of I is a two-valued function. For example, if you give 1, what is square root of 1? This is not only 1, minus 1 is also a square root. Okay, so square root gives always two values, but principal square root means this is a unique square root. So basically it is one of the square roots. Well, before we go to square root of I, let us take a general complex number z. Well, for this we can write the polar form, which is given by r cos theta plus I sin theta. Where is r? R is the modulus here and theta is the principal argument. We want to consider the principal argument here. Well, so what is the meaning of principal argument actually? So theta qualifies to be a principal argument when theta is strictly bigger than minus pi and less than equal to plus pi. Well, so if this theta is principal argument, then z to the power 1 by n, which means what? The nth root of z, or to say nth roots of z, are given by r to the 1 over n cos theta plus 2k pi by n plus I sin theta plus 2k pi by n. And what are the values for k? What is k here? K actually ranges from 0 to n minus 1. Pretty much you can take any value of k, any integral value of k, but all of them will give you repeated value. But here there is no repetition if you take k to be from 0 to n minus 1. Well, so then these are all the nth roots of z. Which one is the principal nth root? Okay, the principal nth root corresponds to the k value 0. Okay, so if you put k equal to 0, whatever you get is the principal nth root of z. So let us put k equal to 0, then the principal nth root of z can be given by z to the 1 by n, which is r to the 1 by n cos theta by n plus sin theta by n. We are simply putting k equal to 0. So this is the principal nth root. Now if we take square root is what? Square root is nothing but the tooth root, we can say. So I to the power 1 by 2. Well, then so basically instead of z we have now I, and instead of n we have 2, and it has possibly two values, but we should only consider the principal square root here, right? So I can be written as r cos theta plus I sin theta in the plural form. If you just see what is r is the modulus of I, which is 1, right? So we will not consider r anymore because r is 1. And then if we take theta equal to pi by 2, then I equal to cos pi by 2 plus I sin pi by 2. Cos pi by 2 is 0 and sin pi by 2 is 1. So basically I equal to I, which is obvious. So this identity is surely true. And here theta is what? Theta is pi by 2. But what we have to check, that theta is actually principal argument, or we say principal amplitude. Well, just check this. Pi by 2 is strictly bigger than minus pi and it is less than equal to pi, and therefore theta is actually a principal argument or principal amplitude. Therefore I has this form cos pi by 2 plus I sin pi by 2, where this theta, the amplitude, is in its purest form. So basically the principal form. Well, so then what is square root of I? So by formula here we have seen that z to the 1 by n, the principal nth root is given by r to the 1 by n cos theta by n plus I sin theta by n. So here theta is actually pi by 2, and then square root of I is given by cos of theta by n by n equal to 2 here. So theta is pi by 2, so pi by 2 by 2, which is pi by 4. So root I, or the principal square root of I, is just given by cos pi by 4 plus I sin pi by 4. Well, similar things we can do for square root of -I. So square root of -I is nothing but minus I to the power half. Then again you write minus I as r cos theta plus I sin theta. R is the modulus of minus I, which is well known to be 1. Therefore, we do not need to write r again. So cos of, if we take theta equal to minus pi by 2, we get cos minus pi by 2 plus I sin minus pi by 2. Actually, this expression is always unique if theta is principal. Here we just want to check whether theta, which is minus pi by 2 here, is principal. Well, again, minus pi by 2 is strictly bigger than minus pi and less than equal to pi. This satisfies the identity, therefore, the inequality. Therefore, minus pi by 2 is the principal argument. Therefore, minus I has this polar form where theta is minus pi by 2 and it is the principal argument. Then what is minus square root of minus I? Which means what? Minus I whole power half, right? So then it is again cos theta by 2 plus I sin theta by 2. Theta is minus pi by 2. So we get square root of minus I is cos of minus pi by 4 plus I sin minus pi by 4. This is well done. So this is actually the principal square root of minus I. Now we need just to add them. Okay, square root of I, we got this cos pi by 4 plus I sin pi by 4, remain as is, and then square root of minus I, which is cos minus pi by 4 plus I sin minus pi by 4, and this can be actually written as cos pi by 4 minus I sin pi by 4. Why? Because cos is an even function, therefore cos of minus theta is actually cos theta, and sin is an odd function, therefore sin of minus theta is minus of sin theta. So cos of minus pi by 4 becomes cos pi by 4 and sin of minus pi by 4 becomes minus sin pi by 4. Therefore we get this value. And then square root of I plus square root of minus I is cos pi by 4 plus I sin pi by 4 plus cos pi by 4 minus I sin pi by 4 plus I sin pi by 4 minus I sin pi by 4. They cancel each other. Therefore we get 2 cos pi by 4. But cos pi by 4 value is 1 by square root of 2. So we have 2 times square root of 2 times 1 by square root of 2, which is nothing but square root of 2. And actually we have proved our required and beautiful identity, square root of I plus square root of minus I equal to square root of 2. Okay, yeah, that's all in this video. If you like the content, please do press the like button and consider subscribing our channel to motivate us. I sincerely thank you for watching this video.